Okay, welcome to the class. Morning, everyone. So, homework, right? So, actually come to my office on Monday. We have discussed about chapter 3, problem 8. That's probably one of the hardest. It's not, can't say it's hardest, but the question probably need my direction. So that's the reason I sent an email to the whole class, right? Yesterday evening about how to begin to do the part B of problem 8 in chapter 3. Well, this problem I can't say it's hard after you get the initial idea how to begin with that. When you be able to begin to have the first trend estimates, right? As I have explained in the email, you don't have to go from period 4. You can begin from other period. You really think it's reasonable, right? But well, that's the textbook has this answer. Well, it's also reasonable, begin from period 4, and then the rest step just be careful. From period 4, you make the forecast period 5, step by step, until period 16, 17, 18.
I think the paper that we're turning in, we don't have to include the question itself.
No.
And the same thing with the data, we don't have to include the data.
No. You don't need that. You just give me your solution. Yeah, solution, the detail of your solution. And also, for example, for this question, well, you don't have to write each single step from period 4 until period 16, 17, 18. Definitely 16, 17, 18, 19, I need to know each single step. Right, for example, you give me period 4, 5, 6, right? And then you can tell me, okay, until, and then skip some middle steps, say, okay, I guess like period 14, 15, go on, right? I can trust you. You can't, it's really hard to make a magical number if you didn't get the correct number on period 7, and then you get the correct number on period 14. It's really hard. I think you must be correct. Or you just write me the forecasting for the middle step. You don't need to give me, okay, how you guess the TT and ST in middle step. It can take you a long time. It's pretty tedious. I also want me to enjoy the homework, also like just write each single step. Okay, it's clear? Any other question, let me know, but I think all of you have to begin your homework now. Okay, it's 1 week before the due date, right? I don't like to, after 1 week, you tell me, hey Charles, what's up, bro? I don't finish that. I don't like that. As I explained very clearly, okay, if you fail this class, well, I think that's a lot of is your responsibility. I'm ready to help. I give you 2 weeks. Right? I can answer your questions. My office is always open to you guys. Okay, it's your turn. I also help each other. No copy, but discuss with your classmates. Okay. Continue our study on capacity planning. So, and also last question of the homework is about this chapter. So capacity planning, we have talked about how to calculate the efficiency and utilization for this very simple, like elementary school example, right? Next topic is about determinants of effective capacity. Right? There are so many factors will affect our capacity. Well, for example, your facilities, the design of your facilities. Products and service factor. You think about, we have talked about, if you provide a high level of customization, usually, okay, your capacity requirements maybe not big, but need to be very flexible because you have like 1,000 different products, right? Then when you design this machine or train your employee, you need to let them be flexible. You think about the soda machine in McDonald's, Taco Bell, they can provide like 10. No, not 10, 5, right? McDonald's 5 or 6, okay, different sodas. So this machine have to be very flexible. It can provide 6 different flavors of soda when you go to McDonald's, right? Well, on the other hand, for example, sweet tea. Well, they can't implement the sweet tea in this same machine, right? Because different brand, okay, it's not products of the Coca-Cola. So you have to add just different products, sweet tea or unsweet tea for customer. So that's you think about that. Some products you can easily implement in your current capacity machine. Some other product, if you want to provide a sweet tea or smoothie, then you probably have to buy a new machine or different equipment to produce different products. And also requirement is different. You think about if you have Any of you went to Coca-Cola Center in Atlanta? Raise your hand. Right? Okay, we have like 25 students have gone to that place. So you have seen that, right? In that center, there's the showroom, right? It's all different flavors of the brand of Coca-Cola. Well, that's a machine pretty magic. This one machine can produce like 20 or even 30 different flavors. Well, this machine probably is much more expensive than the machine we have seen in fast food restaurants, right? But it can provide. So in the future, well, that's the Coca-Cola. They already have this capacity, flexibility. But if they can cut the cost or maybe promote to the vendor, okay. And finally, okay, they can expand this flavor to 20, 30 different flavors. Well, in fast food, right, McDonald's. So that's very important. Do you like the flavors when you taste in the Coca-Cola Center?
They have those in fast food places.
Huh?
They do have those in fast food places.
Yeah, they do have. I know you're talking about like Chick-fil-A, something like that. Is that the machine?
No, it's got the big red machine, and you can pick like different flavors to put in your.
I know, but it's not as advanced and as in the center. Coca-Cola Center, like one machine, like John have seen that, right?
From different countries.
Yeah, it's also from different countries. Machine, yeah.
You can pick to put like vanilla, strawberry.
Well, some yeah, I know there's some advanced machine in the just one button, right? You choose the different flavor, right? But still, well, if you go to Coca-Cola Center, you are seeing more advanced machine have more diversity of flavor. One reason is that people maybe you have the ability, but customer here don't like the flavor from Africa. For example, when I taste that, I really suggest if you have time, it's pretty close, Atlanta, right? If you have time to visit Atlanta, that's Coca-Cola Center. For me, is the top priority to try different flavors, right? And also has a like the big pole bell, pretty cute. Daughter really like that, right? So the flavor I really don't like is really the African flavor. Might try each single flavor. I have this goal, right? But okay, when I try African wine, I have to waste 1 minute to try different flavor. Because just for me, maybe you will find African flavors, right? And the second is Caribbean. No, Caribbean is not my type. It's not my type. Asian, European, North American. Probably that's really the continents I have visited. So probably that's the reason I can get used to all the flavors. But that is about capacity, right? Process factor. Okay, when you need to customize your products, right? Is that the last step or the first step? If we from the beginning already have to divide our product or material into different groups, it's definitely increase our burden for capacity, right? Human factor, whether you are flexible, whether you can handle that, what is your working efficiency, right? Working ethic, there are lots of things. Do I need to monitor you? Right? There are lots of things that determine the capacity, the efficiency, how many people we lead. Policy. Okay. Policy is very interesting. Give me some example. You think policy will affect our capacity? Your turn. Policy. How does policy affect our capacity? Mm-hmm. John?
Policy affects everything you do.
I know, theoretically speaking.
Oh.
Yeah. But details, like which policy does affect which company or what type of industry's capacity? Give me some details. So one policy, Dylan?
Maybe like the pollutants in the air or something. Like if you're
Pollution.
yeah,
Uh-huh.
if you're
Okay, yeah, that's pollution. And then what?
that's a certain
Global
amount,
warming, right? It's a global warming.
like a
pollution.
certain amount you can have per day or whatever.
Yeah, so basically, yeah, there's some factory, they have the cap of the emission of the
That's the
carbon,
most
oxygen, right? Very good.
So during my internship over the summer, we had one of the policies was that we entry analysts and interns did not communicate directly with the clients.
Uh-huh.
We had to go through somebody with a higher ranking or
Right.
yeah, and so that made it less efficient
That's right.
in the way we were working because we had to go through somebody else in order to get the question we needed from the client.
That's very good. That's very cool. I didn't think about that, but yeah, this is about the human resource policy. It's not the exact government or like the pollution, right? It's like if you have this policy, some people, you technical people, they think you have poor or not so good communication skill. They don't want you to direct face your customer. So you have to tell the sales and marketing people first and explain, okay, what's the problem, how they solve it, and then they face the customer. So definitely, it affects efficiency. It definitely also affects our capacity ability, right? Another thing for international students, for example, if you have internship, let's say, and regular semester, you can only work at most 20 hours per week. Well, for the local student, you don't have this limit. I know some students work 40 hours, but still, it's full-time student. It's your choice. But for international student, you can work at most 20 hours. So which means you have the capacity, right, for working for the company. Or if this company hire you, it's already the policy, but the immigration policy, right? But if they have the local citizen, okay, they can use you 30 hours if you can handle that, right? Nobody suggests you to work 40 hours and select 5 classes. Another thing you think about the policy is about the government, or local governments or community, right? For example, HOA, right? For HOA, many people don't like HOA because the HOA so you have to do the yard work like once per 2 weeks, right? You don't put the garage trash can outside of your garage, something like that. Well, you think about government, same, right? Especially in the US and Europe, they have very strong policy. Like Europe, they have probably the most strict policy on pollution. So the company, think about Europe 2 years ago, they charged the airplane company the tax, the emission tax. Well, I'm not sure, I didn't follow up this story. Well, they charge United Airlines, American Airlines, charge Air China, but all Japanese airlines, they charge not just European airplanes, right? They charge all the countries, your airplane fly out from Europe, they charge the emission tax. Well, definitely, so many companies doesn't like that, right? So, but this give you some constraints. Okay, what is cap? For example, you can only work probably, I don't know, construction industry here. I don't know, maybe from 7 to 5, to 8, something like that. That's his time. Okay, they say okay after 8 p.m. everybody have to go to sleep, but you can't work overnight except some emergency. Probably you have. But in developing country, the policy is different. For example, okay, last year when I went back to China, so 3 years ago, last year they already have this building. So our neighborhood, of our community, that's a building they build up, like 20 floors. They want to sell the condo to the people. Well, they work really hard, make progress every single day in the weekend, like 6:30 a.m. I'm not an early bird. 6:30 a.m. is too early for me. Boom, boom, boom. Because they build 20 floors, it's not like we build a single family house, right? So it's very noisy. I complain a lot. Who allows them to work like 6:30 a.m. right? And then I have a friend. It's very interesting. I have a middle school classmates. We have a reunion. That's a party later. He worked in the government about to set this policy. Okay, when you can begin your building doing. He told me, okay, the earliest time is 6:30. That's the policy. They didn't well this policy. They can work until 10 p.m. They just work from 6:30 to 10 p.m. Probably that's the reason they have this building finished in 2 years. Okay, that if you work only like 8 hours, 5 days, you can't finish that so far. But the problem, I really hate that. Myself, every morning, I really want to complain. Okay, call the government and I get the information from my middle school classmates. Okay, that's the policy. But think in US, probably in Europe, we have even stricter policy. Right? Probably only like from 8 to 5. That is, okay, wait, nobody is hurrying. So you can see that's a different policy. You can't say which is correct or not correct. But when you, especially you go internationally, you have to know this policy. You can't say, okay, why Europe charge higher tax on emission? Okay? Why China allowed to work for longer time? Well, they have their policy, right? So that's it. Operational factors, we have discussed a lot. Okay, it's possible about collaboration, right? Your forecasting, inventory management, where they can improve your capacity. Supply chain. Your supplier, you don't get the material, there's nothing you can do, right? External factors. External factor can be the weather, can be the hurricane, can be the flood, can be the earthquake, the disaster, can be good things, right? Events, Super Bowl, football game, a lot of things will determine our capacity. Okay, when we talk about for the capacity planning, it is a long-term decision. So the strategy should be based on some assumptions and prediction about the long-term demand pattern. It's not weekly, it's not even monthly. It's talk about next year, next 5 years, next decades. When Walmart decide to open a store, you can think about it. They are not thinking about even next year. They think about next 10 years. Because you open a Walmart store, it's very expensive. It's even more expensive to close this Walmart store if they have to do that, right? So definitely they have the break-even point. They say, okay, since next 10 years, I earn like $1 million. If I have to close this store after 10 years, at least I don't lose money, right, by making a decision now, right? If you only think about 5 years, you maybe earn $500,000 in 5 years, but when you have to close after 5 years, you still lose a lot. So that's why when you talk about capacity planning, okay, or add a machine, okay, for example, yeah, same thing, right? How more important is long-term decision. So long-term demand is very important, forecasting. Technological change. Any example? How it will affect our capacity planning? Technological change.
I think the easiest thing is the computers, how much the computers can do for us.
Yes.
If you look 10 years ago, how much a computer could help you compared to today.
Yeah. Computer, software, what they can do. Another thing is that like robots, something like that, it also can change a lot. It's not just about the advance of technology. Think about the communication. Same. Okay. 10 years ago, okay, you have the supply in like Malaysia. It's pretty hard for you. And many companies, what they did 10 years ago is they send people, okay, local people. I send John, okay, you relocate to Malaysia for 1 year. I really you to be in Malaysia. So I know some people speak good English or understand our company's policy, and they are to contact us. But nowadays, many companies, they don't need to do that. They have WebEx, Skype, different technology, right? And then, well, this technology communication is pretty good. It's not just communication, like data change every single second. You know what's happening in Malaysia. You don't need to send some John to Malaysia to look at, monitor, okay? You don't need that. So that is the advance. And no mention as Patrick mentioned, right? So robots, software, they replace people. But on the other hand, they also improve our capacity, most likely. Right? The third one is also very important, competitor behavior. Right? We understand. You make the forecast. First, it will affect our forecasting for sure. When we make the forecast, especially long-term forecast, it's really hard to think about which competitor will come out in 5 years or 10 years. You have no idea. Do you have any idea? 10 years ago, Facebook just began, right? Mark Zuckerberg just started the Facebook. I think I begin to use Facebook in 2007. When I begin to use Facebook, Facebook is still a small website. Well, you add some friend, probably the only 20 friends use Facebook at that time, right? So nobody knows. Microsoft, Google, they don't think, okay, this Facebook will become a huge competitor. That's okay. When you make your demand, you think about like Google Plus. Well, they totally fail. Right? They can't compete with Facebook. Right? They simply can't. Google still is a larger company than Facebook, but just in social network, you can't compete. So when they begin there, for example, another example is pretty sad example, MSN. Have you guys used MSN before? It's Microsoft's product. Yeah. It's instant message, right? And then MSN just disappeared. Well, I remember when I was in college, from 1999 to 2003, MSN is my major social network tool. I log in my MSN almost every single minute. When I first log in computer, okay, it's automatically logging MSN and begin to chat with my friend. Well, I probably have like 200 friends in MSN. Okay, so that is traditional. But in 2000, I believe 2010 something, but nobody continued to use MSN. So Microsoft just stopped. This product has gone. Used to be the dominant in the market because of competitor. Because like later they have Yahoo messaging, you can name that Skype, and then social network like Facebook, Snapchat. I don't know what you use now, right? But so many different tools. So MSN, okay, Yahoo Message is the same, right? They can't survive. When you do the capacity planning, this becomes extremely hard nowadays. Think about the globalization, it's extremely hard. But what we can do is that build flexibility. Well, it's really hard. You think about, okay, 5 years later, who will become the competitor? Even you know, okay, that Google is our competitor. How big of this competition? You don't know. It's really hard. But what we can do is build flexibility. Think about the backup plan. Build the crisis management. That's something you can definitely do when you plan your capacity, right? You don't know, okay, which company, maybe some company from Africa just emerged in next 10 years. You have no idea. what's the culture, background of this company. But what you can do always, okay, backup plan, flexibility, right? Think about crisis management. That's the thing we can do. Okay, talking about flexibility, that is the capacity fusion. So capacity fusion, by definition, is the actual capacity used to offset the demand uncertainty. By definition, calculation is very simple. We get utilization, 100% minus utilization, which become your capacity fusion. So for organization that which have greater demand uncertainty, typically have greater capacity fusion. On the other hand, if your company has pretty standard products, it's only 10 products, and demand is very stable, generally they have very smaller, much smaller capacity fusion. Clear for you? Reasonable? Look at these two sentences. That means reasonable. If your company have, so for example, okay, a lot of different products and your demand fluctuation is very high, you want to keep a high capacity fusion, which means, okay, in case emergency happen, you have emergency production plan, right? Because you have like 30% gap. You run 8 hours per day, 5 days, right? Okay, your utilization is 70%. Well, so fusion is 100% minus 70% is 30%. Well, if something, okay, fluctuation, okay, demand is really high, then you can work, if not 24/7, maybe 16/7, like 16 hours per day, 7 days. Then you can almost double the more than double your capacity, right? That's the thing you can do. On the other hand, if you like have a bottle of water, you are producing water, right? That pretty standard products with stable demand. You don't need to have like 30% fusion. The demand can't fluctuate so much. Right? Don't need to. Okay, steps in capacity planning. So we're talking about the first is that future capacity requirement. How can we know or estimate the future capacity requirements? Who can tell me? How can we estimate the future capacity requirements? Forecasting what? Future capacity. When we talk about capacity, it's really 5 or 10 years later, right? How can we estimate what we need in 5 years later? The first step, what we need to do?
Demand forecast.
Demand forecast, exactly. And first, you forecast the demand, it's long-term demand forecast. How can we convert our demand to our capacity? Like for example, if you forecast, okay, 5 years later, okay, our like the monthly capacity requirement is 1,000 units. Like say Mercedes-Benz, that's our factory. We need to produce 1,000 units Mercedes per month. If that is your demand forecast, how can we convert to our capacity requirements? Capacity means, okay, think about machines, how many machines we need, how many people we need, for example. How can we convert this demand to our capacity? So I give you 1,000 Mercedes cars we need to produce 5 years later per month. And you have to tell me, right? Then after 5 years, how many machines we need, how many people we need? How can we estimate that?
Well, if you take what you're producing now, and let's say you have to make like 250 more, you can take, like each machine makes 500 cars, let's say.
Yes.
You need another machine in order to make 1,000.
Exactly. So you calculate the working conditions of machine or people, right? Well, definitely, it's one thing we want to, it can change after 5 years with the technology progress, with the training, or with the design change. But general idea, what you have the machine, right? If this machine can produce 500 units per month, okay, that's very simple. 1,000 divided by 500, we need 2 machines 5 years later to handle that. People is the same, okay, if we now produce 100 cars per month, we need, let's say, 100 people working in this factory. Then we double the quantity, we double the people. Right? That's a very simple conversion factor, but it can be more complex. You think about right, economical scale, 5 years later, technology change. Well, that's the reason we always want to build this flexibility, okay, when our do the capacity planning. Okay, now you guys future requirements, then look at our current capacity. Machine, we only have 1 machine. We need 2 machines 5 years later. only have 100 people, we need 200 people, or at least more than 100 people later. We identify these gaps. Now we know, okay, if we want to meet this to produce 1,000 Mercedes, okay, in our factory 5 years later, then we have to improve or increase our capacity. There's so many ways we can do that. For example, by advanced machine, okay, more advanced machine. Well, we keep the same 100 people. The machine is more advanced, we don't need 200 people. Or have more people, still one machine. That's a machine run 16 hours per day instead of 8 hours. So we have 2 shifts or 3 shifts work together. Okay. Another thing is probably it's hard to do outsource, but you can. Many companies they can. Mercedes probably is hard, but some other company definitely you can choose outsourcing, right? Then you have different ways to meet these requirements, increasing capacity. Next is most important part for us is to do the financial analysis. Yeah. We can talk about it. Probably you don't need to come to this class. We have so many choices. But in this class, in the manual, we need to learn, okay, you do have so many choices. You know the trade-off there, but do you know the exact trade-off? That's the number talks, right? We need to analyze exactly. I know it's still estimation. It's not the real number 5 years later, but we need to get some number, right? Calculate. Then, number is important, but also some other important key qualitative issues. For example, we all have debates, right? Outsourcing is always a choice, most companies, to solve the capacity problem, right? It's always a choice. But outsourcing, compared to buy more machines or have more people, outsourcing probably is the most valuable, okay, policy if you want to implement to solve your capacity plan. Right? Because this is really qualitative. It has nothing to do with your financial analysis. But if you do outsourcing, right, local community, local governments, even your inside employer, they have their opinion. Opinion is fine. Usually, opinion doesn't hurt the company itself, but the opinion can change, become attitude. They can change the policy. The attitude of your employer can change, and then lower the working efficiency, lower the working ethics, can become a problem. And finally, it's what showing the number. So that's qualitative factors can be very important, especially if you talk about policy, right? Outsourcing. Always think about, before you do the outsourcing, think about whether I can solve this problem by ourselves, right? Internally. Okay, you try hard, if it can't work, then maybe outsourcing is a good idea. Select the best alternative for long term. It is a long-term decision. Okay. Implement the method and then monitor. This monitor is not like forecast every five months or half a year monitor. Probably like several years. Because capacity, when you decide that, even you monitor after half a year, you can't change because it's too expensive. Right? It's really hard to change. Forecasting. Okay, that's related to chapter 3, right? So it's related to the overall level of capacity requirements. The forecasting is over time horizon, and we convert those leads into capacity requirements as we have discussed. You have 1,000 is forecasting. You convert to how many machines, how many people you need to produce these 1,000 units. And we also consider short-term forecasts, okay, related to the variations. We don't consider too much about cycles and trend, but we need to think about seasonality and other variations, so we can adjust our capacity plan a little bit for the short term. Okay, now we have some serious maths. From elementary school to middle school, we might go higher and higher, and finally come to our level. So if we want to calculate the process requirements, okay, for example, how many machines we need that? And here's the formula to calculate the number of required machines. Given different products, okay, products 1 to products K. K can be 10, so you have 10 different products. So we first need to calculate the total processing time needed to produce these K products. So to calculate this is very straightforward. We sum together I from 1 to K, PI, which is the standard processing time for each product I. For example, one product 10 minutes per unit, another product maybe 5 minutes per unit, right? Then you use this standard processing time per unit multiplied by your demand. Okay, if your product one is the water demand is pretty high, it's 1,000 units, and then you times 1,000. Another product is maybe sweet tea. Sweet tea is much smaller demand, it's 100, right? Then D2 is 100. You add them together, which become your total processing time needed to satisfy all the demand, DI. Right? All the demand. It's clear? PI, DI is the processing time for products I. You sum them together, that's the total processing time you must have to satisfy your demand for these all K products. That's the numerator. The denominator is pretty straightforward. It's the processing time available during this planning horizon. When we talk about demand, is weekly demand. That's how long you can run this machine, 1 week. If that's monthly demand, how long you can run the machine per month. Divided by T, and this will give you a number, how many machines you need. Very straightforward, right? Any question, comments before we move to the example? Question, comments, or just you to copy the formula, right?
So I equals, when it says I equals 1, that's because you're starting at the first one?
Yeah, because think about, so let's say we have A, B, C, 3 products, right? So PI for A is like 10 minutes per unit. 5 is B is 5, C is 8, right? Then demand A is 1,000 per month, 500, 800, something like that. Well, that. So for product A, which is in fact product 1, right? So here case 3, right? 1, 2, 3, right? And then what you do is that, okay, here is the units per unit processing time. You times 1,000 demand, which will give you 10,000 minutes, right? So this machine, maybe several machines together, they have to run 1,000 or 10,000 minutes to produce 1,000 units of product A. Agree?
Yeah.
Because each product A requires 10 minutes. 10 times 1,000, so it's 10,000 minutes. So that means just to satisfy the demand of product A, we have to occupy the machines. Because one machine or starting machine, we don't know. 10,000 minutes, right? Similar, we do the same thing for product B and product C. When put together, which is the total minutes or total time we need to run the machines. Right? Then we divide it by the capacity of single machine. So T is the capacity of one machine. Then we know how many machines do we need. It's clear, Jennifer?
I'm still don't understand where the I equals 1 comes into.
So 1 is that's here. 1,
Okay.
2, 3. Right?
So it's
We
just
label
telling
that.
you, it's just telling you the starting point.
Yeah, it's just tell you. It's just you count how many items you have, how many products you have, right? You can begin from 2, but really usually we begin from 1. The first product, the second, until how many products you are handling.
Okay.
Yeah. So if you have K products, right? Let's say now we have 3.
Okay.
You can label B as 1. It doesn't matter. Generally speaking, we have 3 products, right? So from product 1, 2, 3, we sum them together.
Okay.
Yeah. So that's the general idea.
It's just the I equals 1 is throwing me off.
Yeah, that's
Because I
is the-
understand what the K
Yeah.
sum is, but it's the I equals 1 is just kind
I equal to 1 as the bottom of this summation sign means, okay, this summation begin from 1,
of. Okay.
end with K.
Okay.
It's clear?
Yeah.
Okay. I know many of you don't have mathematical problem because for me it's so straightforward. It's like in my gene when I was in, because I studied math for so long. So for the summation sign, the bottom for this summation line means, okay, you begin from I equal to 1, right? The top of this summation sign is the ending point until K. So when you plug into this PIDI, so you begin from P1 D1 plus P2 D2 until PK DK. Right, like this example, K is equal to 3. Clear? I can be very slow if you have a question, right? So don't worry about that. Okay. It's clear? Nobody have question? Nobody? Okay, good. So now we have an example. So this department works, so 8-hour shifts. They work 250 days a year. I'm pretty sure they are in the developing country, right? So I think from this information, well, I think most companies in the developing country, 250 days per year? Okay, that's too short. We have like, well, that's like more than 100 days off, right? That is normal. If you have 2 days off, right, every weekend is already like more than 100 days off, plus the vacation time. Right. So it's pretty typical, right? 5 days working hour and then right 8 to 5, right, something like that. So it has these figures for the usage of a machine that is currently being considered. So we have 3 products, very simple, right? The annual demand for products 1 is 400, and the processing time per unit for products 1 is 5 hours. Product 2, 300 is the demand. 8 hours per unit for process time. 700 demand for product 3, 2 hours per unit. Now, what you want to do first, you calculate. So here is the DI, right? D1, D2, D4. This column is a PI. Okay, processing time P1, P2, P3. You multiply them together, you get the processing time needed for 1, 2, 3. You sum them together, then you will get the numerator. Denominator can be a little bit tricky. How to calculate T? That's what I'll give to you. Okay, I'll give you guys 8 minutes, should be enough for you to solve this problem. That's why you use this to multiply, right? So it's PI times D, right? This is D, this is P, right? Yes.
Yeah, I think so.
Yeah, and then what's next? You need to sum. You need to sum them together. So you have PI, DI. And it's multiplied, right? I from 1 to 3, you sum them together. And that's the numerator.
Demand.
PI is here, processing time, right? Yeah. This is D, right? Very demand, right? DI.
That makes sense.
So this PI and DI.
That's right.
Wait, why'd you put them in two?
You do something together, right?
8 hour shift.
Times 2.
This is gonna be
You mean the numerator? You have to add together, right? Summation I from 1 to k. Well, is this example k equal to 3? We will have 3 products. Yes, yes.
Right here. That'd be a numerator.
Yeah, you still need to figure out the Okay, so you get this number. How do you get this? 21. So each product, right? You should guess the PID. Right? For example, product 1 should be 400.
You gotta do them. You gotta do them separately.
Yeah, separate.
A lot about a time available.
No.
Doesn't work 250 days a year, 8-hour shifts.
Get that. Very smart.
2,000.
No idea.
Oh, I'm working on it.
Okay. So, why you laughing?
Yours really funny.
Me?
Yeah.
I don't know. I don't know how to comment on your what you said. But anyway, let me help you for this, right?
Okay.
So, do you need to calm down? Or?
No, I'm good. I'm good.
So this is the you have to first calculate summation PI for the numerator. So DI is the demand for each process. So it's 400, 300, DI is the percentage. That's right.
I live at Point anyways. I have to drive anyway. So.
Okay.
Are you sure?
Thank you.
I don't know.
Yeah, that's right.
What you gotta do, you gotta multiply.
That's exactly what I needed.
You gotta add them
That is
up.
exactly what I needed today.
8 times 250.
Yeah, I can try no matter what. It doesn't matter. Wherever y'all want to go.
Oh my god.
But the nice part, right?
Oh wait, it gets harder.
What is time? What do you multiply?
I learned.
Oh, you mean
No, I can't take him over
you mean the
this.
denominator?
That's all I did.
The first one you calculate the numerator.
I cheated.
And divide that by.
I think we all.
5 hours.
Except for
Except
for Dylan.
D1.
Dylan actually knew.
The T is 8 times 20.
I didn't
So the
have
time you
to
have here.
No, I didn't.
So you do 7 hours. 7
I've
times.
never really been in there other than to get food.
You mean which one? T?
Yeah, we did.
I didn't know how to read this formula.
T is
I didn't. Like that first thing that comes down there, that E with the 3.
T is the total working hours.
I think it's
You already got it. Ask her the
Yeah, but I don't.
Yeah, 2.9. 2.9, but it's not the final answer. 2.9.
He's a funny man.
Yes.
He's very funny. So do I need to come back soon? No. Let me help you. Okay. Hey, I should join the economics.
That's right.
Do you know where? What? You should join the economics club with me and Jess. Why? You know where?
I didn't want you to spend
I already do so much. You know our citrus house.
No.
The economics club.
Do you know her side?
Oh,
I wasn't gonna make you. Like, I'm not sure.
Yeah.
join the economics club.
The very end of campus.
2.3 still round
Are we going on like a 2 or 3 food?
Run on a field trip. Where? I have no idea. Sometime the end of this month.
Does it involve free food?
I don't know, probably. Does it involve not getting a
Run up, right?
class?
Final results.
Nope,
you have
you
to
get
run up.
excused.
Question. Okay. So
Friday.
I kind of have
Come to band.
And
Just do it, Chad.
Yeah, you first
cost money.
Not yet.
Yeah. Ideally, should be running even 2.1. But it's really depends on company strategy. Say, okay, I will run this.
Might join.
But if
Right,
you
but
check
we're
it
looking at how
Yeah.
many.
if you have the supervisor, you have to match on
Yeah,
the 0-1. You have one card.
Oh, yeah, job next year.
But for this example, it's pretty, they don't want to buy 2.9. Obviously, you should run up.
Right.
Not run down, right? You don't want it
You just come to a meeting.
0.9, that's the minus. Okay, very good. I can see most students have finished these questions. Very good. So let's do that together. So we calculate PIDI for each product. For each product 1, what is the total process time? 2,000. Product 2, 2,400.
Okay.
Product 3,
I just have 1,500.
so add them together, 5,800. Okay, so for this part, the numerator become very straightforward. So 5,800
Who's talking?
hours, working hours. Now, the hardest part in this question is in fact how to determine T. T is, think about T is the one machine's available working time given this year. First, time horizon is year, right? We're talking about 1 year's demand. So you talk about machines also 1 year. You can't say, okay, your demand is annual demand, and then your working hour is monthly working hour. Many students can make this mistake in homework exam. Okay. Make sure that you have the same units of measurement. Now, so T must be the 1 year's working hour for this machine. How do you calculate that?
Can't go.
How do you calculate T?
8 hours.
Yeah, so 8 hours per day, right? The machine can run 8 hours per day, and it's open 250 days per year. Okay, it's clear? 250 days per year and times 8. So we get total is 2,000 working hour. So we get 2.9 machines. Okay, you give me 2.9. Is that the correct answer? No.
3.
You should round up to 3. Okay, Patrick has a very good question. He asked me, okay, is that always round up?
Oh shit.
In reality, not exact. For example, let's say you have 2.0001, which means if you round up to 3 machine, you have overcapacity. You will waste a lot of money by the 3rd machine, right? Because it's only have a very small amounts. Okay, probably you say, okay, sorry to some customer, I can't satisfy you. I only have keep 2 machines. But this example is pretty straightforward, right? It's 2 point. You should round up.
Oh, it's
Well,
8 times.
2.6, 2.3, 2.4, it's really depends. Nowadays, most companies want to satisfy demand. Even at 2.3, you want to buy this machine. You don't want to lose customers, right? But 2.001, I don't know. But maybe some companies strictly, you have to satisfy every single demand. But that's company decision. But this is pretty straightforward. Use your common sense, round up, you get 3. Okay, that's it for today's class. We'll see you guys on Friday.
So, do y'all want to do the help? I'm not sure.
You know,